we are having your, yes, what is the, in adiabatic, you remember, in adiabatic, which law is there? Here, okay, Gay-Lussac, this one, Poisson's law is there, okay? You have to remember this name is somewhat different because these names we see here all the time, okay? This is the your Poisson's law. What this is saying here, this is saying Poisson's law, PV power gamma is constant. Now you will ask, what is the gamma? Gamma is nothing but the Cp by Cv. PV power gamma is constant and this is nothing but the gamma is Cp by Cv. PV power gamma, that is the Cp by Cv. Clear? Gamma is nothing but the Cp by Cv, okay? I can write here. Now, they will ask different variation of each formula. Here we know that in this one, there is no different variation possible. Okay, but in your this, okay, for the adiabatic, some different variations are possible. So I can write some different variation of this one. Okay, what are the different? Poisson's law, Poisson's law. Now, what are the different variation possible for this one? This is the PV power gamma. In terms of, I can write here, in terms of volume and temperature. In terms of volume and temperature, actually you should know how to get this one. So you want to substitute this P, I can write here, nRT by V into your V power gamma equal to constant. So you can say nR is constant. So here I will be getting T into V power gamma minus 1 equal to constant. Or you can say, okay, you're like this also. T1 V1 power gamma minus 1 equal to T2 V2 power gamma minus. Yes. This is basically in terms of volume and temperature, okay? You can find like this if you are confusing anywhere, okay? Yes, adiabatic is very rapid process. I will be writing here, okay? This is a very rapid process. Rapid. This is the condition, very rapid, okay? It is so fast. There is a difference between isothermal and adiabatic. Isothermal is very, very slow. A process is very, 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 very slow. Then we will say your temperature, okay, is constant. A process is your rapid process, means it is coming in adiabatic. Any fast process is your adiabatic. Simple. That is the only difference. Very fast, very rapid process is your adiabatic. And here, then we know if any fast process is there, then in that one exchange of heat will not be there. There will not be any exchange of heat. So we are saying Q is 0, no exchange of heat. If you don't want any exchange of heat, then your walls will be basically your insulating, okay? Insulating or non-conducting, okay? Non-conducting. So what is the difference between isothermal and adiabatic? Difference is only that isothermal is slow process and that is your rapid process. Because of the rapid process, exchange is not possible. This is so rapid. Okay, what is the difference between moles and molecules? Nothing. For you both are same. Now I am here P and T. In terms of P and T, okay, you can attend better class 11th. In that one in chemistry sir will discuss P and T. So we can say in P and T here it will be your nRT. Means we need volume here. So P and this I can write here PV, okay. Volume I have to replace. We can write in this and RT by P. So from here we'll be getting this one, and this will be your power gamma. So you can get here in this one P 1 minus gamma into T power gamma equal to constant. Okay. Listen, what happens sometimes we get confusion that in this one mainly, okay, that this is the P 1 minus gamma or gamma minus 1, okay, something like this. So it's better that we can easily, okay, find this one here 1. This is the 1 minus gamma T power gamma, and we can solve the things. Either numerical based on this, either these formula, okay. We will take some numericals, but generally they are asking here formula. Now, so we have seen in this one what are the conditions required. If slow process is there, then we know what is this. If rapid process is there, then this is the adiabatic. In different formats we have seen. And now, what are the conditions for this? What questions they are going to ask here in this one next thing? Your work you need to remember for all process. So I can say work. Work is basically your P delta V. Okay, integration of P dV we can say. So when we are getting for this one volume constant, there is no displacement, so work is zero. Work is zero. Sir, pressure and density relation with adiabatic, please say. Okay, density is the, okay, what? Volume opposite. Okay, I will say pressure and density relation. I will just write here. There is nothing, okay. Pressure and density, someone is asking, sir, how to do this one? You can say pressure and volume is what? Everyone knows volume is the mass by, okay, can I say like this? Density is mass by volume. So we can say volume is nothing but the 1 by rho. So you can put here in this one P, and this will be the what? 1 by rho. So P by rho power gamma will be constant. This is the thing. P by rho power gamma will be constant, which volume is opposite of density. P by, clear? Means you can write, when you have to solve the numerical, you can solve like this. P1 by P2 equal to, we can write rho 1 by rho 2 power gamma. Like this we can solve your numerical. Clear? Now, so we can say in this one, I was talking about your okay, work for different process here. So we can say work for this is, okay, what are the work for isothermal? We can say W is 0. What will be the work for this? We can say work for this is going to be for under constant pressure. We can say work is going to be your W equal to, we can write NR delta T, or it is the P delta V. I will ask questions on this one, work. They are asking also questions on work. W equal to NR delta T or P delta V. Here I can say in this one, W formula is 2.303 nRT log V1 by V2 or V2 by V1. Yes, 2.303 nRT log V2 by V1. We can write this formula like this also, 2.303 nRT log P1 by P2. This is also the same thing, P1 by P2. Okay, because you know P1 V1 equal to, everyone knows P1 V1 equal to P2 V2, P1 V1 equal to P2 V2. So we are writing V2 by V1, P1 by P2. We know PV equal to nRT. So here in this one, okay, where I have written this nRT, I can write here like this also, 2.303 P1 V1 into log of V2 by V1. Okay, because sometimes they may not give you temperature and moles, they will give you only initial pressure, initial volume, and final volume. Then they will be asking the work done. Okay, we can easily find that. So this is the work done for this. How to remember work done formula for your adiabatic? Okay, because what happens in this one, in adiabatic, sometimes NR delta T by 1 minus gamma or gamma minus 1. Here only confusion happens. NR delta T by 1 minus gamma or gamma minus 1. Because somewhere you have seen different materials, so somewhere they are writing gamma minus 1. Aha told 1 minus gamma. Then becomes confusion what to remember, 1 minus gamma, gamma minus 1. Okay, now see. Here, what you need to remember in this one, Q is 0. Q is 0. Our first law is saying Q equal to W plus delta U. This is our first law. Q equal to W plus delta U. So I can say Q is 0. So W will be what? Minus of delta U. So always you need to find change in internal energy in your adiabatic process, nothing else. Whenever any numerical is coming, numerical you have to proceed like this, that W will be the minus of delta U. Okay, W is the minus of delta U, nothing else. Okay, change in internal energy, negative of change in internal energy is the work done. Okay, and change in internal energy you can easily find, because internal energy formula is always minus and CV delta T. This is the formula of internal energy everywhere. Formula of internal energy, this is not going to change. And CV value we know for each gas. CV value we know, CV is the FR by 2. After this I'm going to put the values here. So we can say CV we know, so we can put the things. Okay, so we can write here W equal to minus and Cv will be your R by gamma minus 1 into your delta T. Then we can put here, this is the, okay, R by gamma minus 1, or I will write after this. Then we can write here, if you take this W minus inside, so it is coming NR delta T divided by 1 minus gamma. Okay. Now, this formula we are getting from this fact that W is nothing but the negative of change in internal energy. So you have to find always change in internal energy. They are saying sometimes they will be asking what are the, okay, what are the final temperature. Work done will be given to you. So we can say if work done is given, we can say that work done, they will be saying like this, work done on gas or by gas, something like this. We can find our internal energy, then we can proceed. And our delta T by 1 minus gamma. Clear? Yes. Next thing is coming about your, in this one, your graphs for all the process. For all these process, we need to remember the graph and then slope. Then I will be going for your numerical part on first law and all these things. But this is the one theoretical segment. Anyone having problem in the formula part? This is the formula for your NR delta T by 1 minus gamma. This is the formula for this, and that formula for these are upside. Now, what we can say if they are asking graph here, okay. Now, for the graph, we can say in your isochoric, volume is constant. And if volume is constant, then what type of graph are possible? We can say volume is constant in this one pressure is constant, here temperature is constant, and here your, okay, PV power gamma is constant. Here PV is constant. Here pressure is constant, so you can say volume proportional to T. And here volume is constant, so we can say in this one P proportional to T. First graph they can ask here in this one, if I give here pressure and here temperature. This is the pressure and temperature graph. They can ask, you know, P proportional to T graph will be directly going like this. They will be asking P and T graph is given to us that A to B, what is the work done? What is the work done when we are moving A to B? We can say work done in A to B is 0 because this is the isochoric process. Okay, isochoric process. Delta T is T2 minus T1. Yes, delta T is T2 minus T1. Here we can say volume proportional to T. You know, this process is going to be, they'll be saying what is the work done when we are moving A to B. We can say this is the isobaric process, and for isobaric process, it should be P delta V or NR delta T here. Now, for this one, we can have graph like this. PV, I can take P or V here. You can say PV graph will be like this. I can say, because whatever graphs I have told in Boyle's. In Boyle's law, whatever graph I have told you, all graphs are possible for this one, all the graphs. If you remember 4 or 5 types we have seen, all things are possible in this, okay? Like this also you can say, okay, if I draw 2 isotherm, then 2 isotherm will never intersect each other, okay? 2 isotherm will never intersect each other. 2 isotherm are always parallel. 2 isotherm are always parallel. Why? Because if this is the temperature T1, this is the T2, here at all points temperature will be T1. Temperature will be same. Here also at all points temperature will be same. Okay. Temperature must be same throughout the process. So we can say an isothermal temperature will be same throughout the process. Okay. Now, so this way we can say these graphs. Here we can say P proportional to 1 by V power gamma. If you, okay, if you say volume increases, ultimately our pressure is going to decrease. So we are getting, okay, your inverse type graph also the same way. P and V graph is this thing. Can we remember this thing? Yes. Now I can ask PV graph here in this one. Okay. Here also PV graph I need. P here and V. PV graph. Okay. Here also I need PV graph. In our thermodynamics, PV graph is somewhat important. Okay. PV graph is important. Okay. PV graph. So you can say PV graph. So PV, here volume is constant, and if volume is constant, then you can cut that axis. Volume constant, you can cut that axis. This is representing your constant volume. Pressure constant, you cut this excess pressure. So this is representing your pressure constant. Okay, pressure constant. Graph for all are written here. Because area of PV graph represents your work. Area of PV graph represents your work. Okay. Do graph 3 and 4 look like? They look like, but they are not same. Okay. They look like, okay, but they are not same. They are not same. Okay. I will tell, okay, how to identify between these two. They are not same. Okay. How to identify. In next point, I'm going to tell. Okay. Yes. Next point, I'm going to discuss how to identify isotherm and adiabatic curve. They look like same, nature is same, but actually they are not same. There is a difference in the slope. Okay, so that is the next point here. Next point is saying about the slope. Okay, slope of PV curve. Listen, what is the area of PV curve? What area of PV curve represents? Area of PV curve represents work is not the area. Work is the area of PV curve. This you have to remember. Okay, work is not area of any graph. Work is only area of PV curve. Clear? Work is area of PV curve. Okay, PV curve, not any curve. If I say VT curve, no. PT curve, no. Only your pressure and volume curve. If I ask slope here, we can say slope is dP by dV. Okay, slope is your dP by dV. So we can say slope dP by dV, you will find what? Tan theta. And tan theta, if I write tan 90, tan 90 is what? Because here you can say this is the 90 degree, tan 90 is. So slope for this is your infinite. Or we can say like this also, dV is, what is the dV? Change in volume is 0. And if change in volume is 0, if you divide with 0, what you will get? Infinite, simple. Okay, change in dV is 0, change in volume is 0. That's why this is the infinite here. You can say, sir, what will be here in this one? You can say slope dP by dV. Now without angle also you can say, sir, here change in pressure is 0, angle also 0. Okay, we can say this is the tan 0. So tan 0 is coming what? 0. Or you can say, sir, dP, there is no change in pressure, no change in pressure, dP is 0. That's why this is 0. That's why this is 0. Clear? Now here we can say change in volume. Here in this one, slope is, okay, slope will be dP by dV. We are getting minus of P by V. Minus of P by V. Okay, how to get this relation? Because you know, in this one, if you remember P proportional to, can I write like this? P proportional to V power minus gamma in adiabatic? Yes? Because if you remember here written na, P proportional to 1 by V power gamma. From here I am writing. Okay, from here I can write like this, and then I can use your I can use your change method. What change method is saying? We can write like this: dP by P means delta P by P. Delta P by P, power will be coming outside, equal to minus gamma dV by V. So from here we can write in this one, dP by dV is coming as what? Minus of gamma P by V. So here power is 1, that's why minus P by V. So graph looks like same, but there is a difference in slope. And you have to remember slope of isothermal, slope of adiabatic, and actually slope of all. Slope of all we need to remember. Can we remember slope for all? Yes? Any problem in this one? Slope for all. Okay, dP by dV. Okay, we got this thing. Y minus, power will be coming outside now. P proportional to 1 by V power gamma. V power gamma will be going upside. So V power minus gamma. V power minus gamma. Okay, then minus you can take downside. Okay, now in this one, if I ask here what are the relation between slopes, so you can say relation between slopes, we can easily find minus P by V. Minus P by V is the slope of this. So we can write here slope of adiabatic, this is the slope of adiabatic equal to, we can write gamma into minus P by V, gamma into minus P by V. Minus P by V is the slope of isothermal. So we can write gamma into slope of isothermal. So which slope will be more? You can see from this expression here. Slope of isothermal and slope of adiabatic. Which slope is more? You can find slope of adiabatic is gamma times of slope of isothermal. Gamma times of slope of isothermal. Gamma times of slope of isothermal. Clear? Can we remember this thing? Yes, gamma times of slope of isothermal. Okay. So these are your slopes. Okay. These are the graphs. So this thing we have just compared all the things. Now I will be asking questions on this. Which have more slope? Then you have to remember adiabatic will be having more slope. Okay, adiabatic will be having more slope. Slope of adiabatic is more than isothermal. More than, okay, slope of isothermal. Okay, and which will be having more slope? More gamma, that curve will be having more slope, because gamma is different for different process. So we can say if gamma is more, then ultimately slope will be also more. So we can say more gamma, more slope, more gamma, more slope. Okay, that gas will be having more slope, which is having more gamma, more slope. Adiabatic is having your more slope than the isothermal. Okay, now clear? Adiabatic slope is more. Adiabatic slope is more. Okay. And how you will get this one also we can find from here. I hope everything written till now it is clear to you. Which clear? Now we'll compare all the factors. So first I have to go for this. Okay, gamma values. Gamma is your Cp by Cv, means listen, for monoatomic, for di, for polylinear, for non-linear. Degree of freedom, we know this is the degree of freedom here. This is going to be 3556. Degree of freedom is 3556. So we can say Cv is going to be Fr by 2. So this value will be your 3R by 2. This is will be 5R by 2. Here also 5R by 2. And this will be the 3R. Okay, this is the 3R. Value of Cv. You should remember this table anyhow. Okay, now then we can write here in this one Cp. Cp will be nothing but the Cv plus R. We can add R here. So 5R by 2, 7R by 2, 7R by 2, 4R. Okay, 4R. Then gamma is nothing but the Cp by Cv. Gamma is nothing but the Cp by Cv. So we can write here gamma is coming as 5 by 3, 7 by 5, 7 by 5, 4 by 3. 4 by 3 is 1.33. 1.4, 1.4, 1.67, which is having maximum gamma here, which is having maximum gamma. Your monoatomic is having more gamma, more slope, more gamma, more slope. Now, I will ask question here that in this one, isothermal and adiabatic both are having negative slope or positive slope. Isothermal and adiabatic both are having your negative slope. Both are having what? Negative slope. Okay, means if I'm giving here these two curve, okay, if you can say A, B, C, D, C and D. What about C and D? C and D are having positive slope or negative slope? You can say in C and D positive slope is there. C and D are the positive slope, or you can say in C and D, if you see that volume increases, pressure also increases. In C and D, volume and pressure both increases. While we know in our isothermal as well as your adiabatic, volume increases, then pressure will decrease. One increases, other decreases in both. Okay, so we can say C and D possible or not possible? Not possible. Now we are left with A and B. A and B. So you can say how you will find more slope. You will release the ball. Take the ball and release. In which ball is coming fast? Okay, in which ball is coming fast? So you can say here in this one, okay, if you release the ball, then in A coming slowly, and in B coming very fast. So we can say your B fast means your adiabatic. Coming slowly means it is the isothermal. Can we identify this? If two curve are given to you, which are the isothermal, which is the adiabatic? Means nature is same, but slope is different. Based on the slope, we need to identify. Based on the slope, we have to identify. Yes. Now giving one more question here. Suppose, and this table should be remembered. Without table, you cannot solve KTG as well as thermodynamics. A lot of questions are based on this table only. Why C and D not taken? And C and D not taken because slope is positive. Slope is positive. Slope is positive. Second thing is that in this one, pressure is increasing. You can say pressure is also increasing here, as well as volume is also increasing. In this one, you can find your pressure as well as volume, both are going to increase in this. Okay, both are increasing here. Both will be increasing. Okay, that's why. Okay, your process not possible. Okay, now if I give you a second question here, see this one. The second one you have to identify. In second, if I write like this, they will ask, okay, which graphs identification, four options they will give, or match the column, or anything they can give you. Okay, now we need to identify these are the four process. So we can say, first of all, this upper process, everyone knows upper process is isobaric. Okay, isobaric. This process is cutting the volume axis, so this should be isochoric. Isochoric. Now only two are left, and two are left. In between these two, we can easily identify. Lesser slope is the isothermal. Slowly coming is the isothermal. This is the isothermal. This is the adiabatic. Yes. Any problem here? Yes. I don't remember any trick. BTAC. I don't know what trick you are saying. Okay, you remember the trick, and they will tilt slightly, and then your trick will be just okay gone. So don't remember any trick. Okay, just go by the bound of your basic concept. Yes, clear. Cutting this one pressure axis isobaric, cutting this isochoric. Okay, now clear. Why your trick will be gone? Because you are remembering like this, and they ask like this, and they ask this one. Now, they may ask their choice. Okay. Now, what we can do, we know this process is your. We know here in this one, this process isobaric, this process, means this process isochoric, this process is isobaric. This process we can say now, here this upper one is having your more slope. So this becomes your adiabatic. This is the isothermal. Clear? Done? Okay. Now, can we go for next? Next question. Now, next one. So these are the two. Okay. Here I am representing expansion, and here I am representing your contraction. Actually, okay. This graph is representing your expansion. We are coming like this. Okay, and this graph is representing basically your contraction. We are going this way. Okay. So now expansion and contraction. So in expansion and contraction, one graph is not possible. That is the isochoric. And isochoric expansion contraction possible or not possible? Not possible. Okay, not possible expansion as well as contraction. Okay, send that slide in group. Okay. Now focus on here first of all. Okay, try to get all these things in here. Okay, now. So we can say expansion, this type, okay, this type expansion, this type your contraction. Question I am giving here, they are saying a gas is expanded. I will write here two parts. A gas expanded from V1 to V2. V1 to V2. Second, a gas compressed from V2 to V1. Okay, compressed from V2 to V1, V1 to V2, and gas compressed from V2 to V1. They will not give you graph, or sometimes they can give you graph. Both type of things they can ask. So suppose graph is given. If graph is given, then they will not give any other information. And the question is written here that we are having, this is the V1, this is the V2. We are coming V1 to V2 expanding like this. And this is the basically three process here. They will be asking what the order of work. Order of work they will ask. Now, both are the identical questions here. So first thing we can write in this one, they are asking here that order of final pressure. What are the order of final pressure? Here pressure is given, here volume is given. Order of final pressure. These two graphs you have seen that previously, okay, upper side also I plotted these graphs, and here also almost same graphs are there. Only one graph are not taken, that is your isochoric, because in isochoric your expansion is not possible. Okay, order of final pressure. Here also order of final pressure. Okay, order of final pressure. So what we can say order of final pressure, if they are asking in this one, you can say final point for this is here. Final point of this is here. First of all, you need to identify. We can say this process is your isobaric, this process is your isothermal, and this is the adiabatic. Here also we can easily identify. This is the your isobaric, this is the your isothermal, and this is the top one is the adiabatic. So we can say here adiabatic is the least in terms of pressure. You can say in the graph it is visible that this is the least, this is the here, and IB is the max. This is the your PIB, corresponding pressure of isothermal, corresponding pressure of adiabatic. So we can write here in this one PIB, then we are having PIT, and then we are having your PAD. Yes. Okay. Now more slope means adiabatic. Here we can write order of final pressure. You can say final pressure of IB is this, IT is this. So this is the final point. You are starting from V2 to V1. It is compressed. Compressed means V2 to V1. High volume to low volume. So you know here PAD is more. So we can write PAD, and then we are having your PIT, and then your P. Here we can say what? IB. Then they can ask in this one, okay? In this one, they can ask, what is your final temperature, order of final temperature? If they are asking order of final temperature, then we know at, okay, for all volume is what? Constant. For all volume is same. For all volume is same. If volume is same for all, can I say pressure is proportional to temperature? Means whatever sequence of pressure, same sequence of temperature will be there, because volume for everyone is same. For all volume is same. Okay. Now we can write here in this one, for temperature we can write for the temperature TIB, then we can write TIT, and then we can write your TAT. Same you can write there also, same sequence will be there. I'm not writing. Yes, can we write that one? Same thing. Okay. Now I'm writing here work. Work is basically your area. Work is given by your area. Okay, means we can say work is nothing but the area. And if work is the area, you can say area for this adiabatic is only this much. IT is from here to here, somewhat more, this much extra. And you can say your IB is what? IB, you can say it is here to here, this much is the your IB. So we can say IB is what? This much. So which area is more maximum? You can say in this one your yes, IB, then we are getting your IT, and then we are getting your AD. Clear? Same pattern here also. Here you will get the exactly same pattern. Done? Okay, same pattern here you will get. Means this pattern will be followed here. These are two important questions in this. How to order of temperature? Because volume for all process are same. Each is having final volume V2. So we can say if pressure is more, then ultimately your temperature will be also more, because volume for all are same. Volume is same for all. If volume is same for all, pressure more, it means ultimately your temperature will be more. Work is given by area. You can say adiabatic area here. Okay, adiabatic graph is downside. I can again say, okay, this is the adiabatic up to this. This is the adiabatic, this thing. Okay, this boundary is the for adiabatic. Then if you go for isothermal, we can say for isothermal, this is the area here to here. This is the isothermal. So of course, this is this much extra, na? So this is somewhat more. If I go for IB, then you can say IB is here to here. This much is the IB. IB is total. So of course, which one is more? IB is more. Area you have to see. In second course, it is reversed. Everything is reversed. Okay, done. Are you done? Yes. Now going for next concept in this. Now, if they give graphs like this, they have given graphs for different gases. Now, You need to identify here which one is the monoatomic, which one is the diatomic, polyatomic. More graph, more slope. More graph, more slope. So we can say this one is having the your least graph, least graph. So we can say which will be this one, least graph. Then we can say least graph means least slope. Least slope means it should be what? It should be your poly, non-linear. We can say this one we can say diatomic. And this is the maximum slope means maximum gamma, it should be the your monoatomic. Or you can remember like this, monoatomic is single will be going very fast. Single is going very fast if it is single. If it is double, then going somewhat slow. If it is triple or 4-pack or 5-pack, of course, it will be going very, very slow. Single will be going the fastest. Okay, so we can say monoatomic is the fastest here. Can we remember this one? If I ask same graph in log, because everyone knows log makes graph straight. Here I am putting log P, and this is the your log V in this. Now, this thing. So I can say, okay, if 3 gases are given, then you can say this will be what? NH3, we can say this will be the O2, and this must be monoatomic, here that is the He. Clear? Now, going for are you done? Done now? Oh. Next thing, listen. Next in this one, if I ask here, okay, your first law questions, okay, questions related to our first law. What questions they can ask in this? We know Q is nothing but the W plus your delta U. Delta U formula already we know, Q we know, W for each process, okay. How they will ask? First thing you need to remember your sign convention. Means if I say work done by gas, work done by gas. Where gas is doing work ultimately, okay, expansion will be there. So we can say work in expansion or work done by gas. It is going to be positive, okay. Work done by gas, or in case of expansion, work is going to be positive. If they are saying here in this one, work done on gas, and when you will do work on gas, when we are, okay, doing work on gas, then ultimately what will happen? It will compressed, and when it is compressed, then we can say in case of compression, it is going to be negative, okay. It is going to be negative. This is the convention of your work here. Now about heat released, if it is releasing the heat released or heat extracted, heat released, extracted, removed, that in this case it will be negative. When heat is released from the system, system is releasing the heat, we are extracting heat, we are removing heat, it is negative because energy of the system will be decreased, so it is negative. But if you supply heat, okay, if you supply heat supplied, if heat is supplied, if heat is absorbed, if heat is absorbed, if heat is added, if heat is given, if heat is absorbed, then we can say this is going to be positive. This is the sign convention that we need to remember, okay. Means if gas is doing the work, very good, gas is, okay, it is the Survey sign convention is opposite in physics and chemistry because of the your work done conditions, okay. You have to remember whatever things told here, whatever it told in chemistry, you have to just remember, okay. That is a system and surrounding difference, nothing else, okay. Reference we can say. Now, so here positive, here negative, this one you can easily remember this one. Someone is saying the downside, and take a screenshot if you want for this graph. Now, I'm going for next some of the questions in this, in the your first law. First law, first question that we are asking here, that 500 joule heat is supplied to the gas. If 500 joule heat is supplied to the gas, then Q you will take positive or negative. If supplied to the gas, then we'll take positive. Okay. Gas performs 200 joule work. Gas performs 200 joule work. So you can put gas performs means it should be the positive 200 joule. They will say initial age 10 joule, find the final. So we get Q equal to W plus delta U, that is the U final minus U initial. Q you can put 500 equal to 200 plus U final minus 10. Now we can say it is coming as 310. Can we solve questions like this? These are the questions on first law, very simple questions. Just you have to remember your convention. Okay. Now I'm going for next question that is somewhat important. Ice to water or water to steam. Okay. Ice to water and water to steam. Water to steam question is somewhat important. So one I will tell which one. Ice to water is also important, but here numerical question not possible because it will be somewhat very calculative. We know volume is your V1. Okay, V1 will be equal to mass by rho 1. This volume will be your mass by rho 2. You know this is happening at constant temperature and pressure. This process is happening. If they're asking phase change is example of at phase change what parameters are constant, then at phase change your temperature is constant as well as pressure is also constant. Temperature is constant, pressure is also constant because okay, atmospheric pressure, this thing is happening at atmospheric. Then you might be thinking, sir, pressure constant, temperature constant, then why volume is not constant? Why volume is changing? Because PV equal to nRT is valid for ideal gas. PV equal to nRT is valid for ideal gas, not for anyone. Okay, you cannot use for ice to water. Ice to water. Okay, someone say, sir, pressure constant, temperature constant, then volume must be constant. Why you are changing volume? Okay, now still how much time is required to complete? Until unless it is not completed, I will continue. Okay, it may take 1, it may take 110, it may take okay, whatever. Listen, V1 equal to M1 by rho 1. They will be asking what is the work done. Work done we will write always P V2 minus V1. Okay, P V2 minus V1, and this work will be coming negative. Why this work will be coming negative? Because ice contract on melting. Okay, ice contract on melting, so V2 is basically less than V1. This work will be negative. Q you can easily find. Q is the MLF. They will be asking delta U, so delta U you can write Q minus W. Okay, delta U they will ask. Clear? Okay, now they will ask when ice is melting, 1 gram ice melts from, okay, 1 gram ice melt from, okay, 1 gram ice melt, then change in internal energy will be more than 80 or less than 80. 1 gram ice melt, 1 gram ice melt. This is the whole one theoretical question. Melt, then delta U, then delta U. More than 80, less than 80 or equal to 80 or equal to 80. Then change in internal energy will be delta U will be, okay, you can say delta U will be more than 80. Why it is more than 80? Because you will write in that case your 80 plus okay, some work will be negative, positive will be there. Okay, so you know that work is negative now, so negative will become positive here. 80 minus W, so it will become positive, so more than 80 will come. This is the one theoretical question. Numerical, because here calculations will be there, so not asked. Okay, now going for water to steam here. Can you remember this thing? Yes. Now, what question they are asking for water to steam? They will be saying when water is converted to steam, they will say 1 gram is basically 1 cc. 1 cc forms 1671 cc. This much steam is formed. Then what are the change in internal energy? We can calculate first of all work done. Work done is P delta V. We can P is the 10 power 5. Delta V 1671 minus 1. So 1670 into 10 power minus 6. We are getting this one 167 joule. And 167 joule, can I say approximately 40 calorie? Can I say approximately 40 calorie? Approximately 40 calorie, yes. Then we can Q equal to MLV. If 1 gram is there, so 1 into 540 or 536, whatever, okay? Because we know 536 is the more accurate value. 540, this is coming as 540 calorie. So we can write here in this one, your delta U will be what? Q minus W. And answer is coming what? 500 calorie. Clear? 500 calorie. Done? This is the one important question in your first law. These two, okay, ice to water as well as your water to steam conversion. These are not entirely based on gases, okay. Can we do this one? Now Now questions on your work done. If questions on work done they are asking, then we don't know, area will give you work. Okay, you have to sir extra class for calorimetry. Today we don't have calorimetry. Today we are having KTG and thermodynamics, no calorimetry. Okay, now what I'm saying in this one, okay, listen, they will be asking here work done. Like if I give giving like this, P here, V here, this is the meter cube, this is the your okay, Newton per meter square. Any area is given to you. Like if I have given this triangle, generally they are asking triangle. One triangle will be given to you and they will ask what is the work done. Can we calculate here? But only area of pressure and volume. Only area of pressure and volume is, I can say this is the V, this is the 3V, this is the P, and this is the 2P, or I can say 5P. Then we can say area of triangle is your half base. Base is what? V to 3V, so we can say 2V, and height is what? P to 5P, so that is the 4P. Like this we have to find our, in any of the question you have to find your work. Work will give you area, simple. Work will give you area. Clear? Okay, now one process we are having, that is your polytropic process. In polytropic process, what you have to remember, whatever process exists in this world, all comes under polytropic. All comes under polytropic. Till now they have not asked more question from polytropic. Only one time they asked. How you will identify PV power gamma equal to constant. PV power gamma equal to constant, this is your polytropic process. I mean PV power x equal to constant. Okay, this is similar to your just like the adiabatic. All the process, all four process also comes under this. All the infinite process which are possible, that will be also coming under this. Okay, now in example of circle. Circle also you need to find just okay, area of that, all the area. I will send you notes in that one. Okay, on this we have done at least you will find around 15 questions, 12 to 15 questions on this. Okay, so you can practice from that. Okay, work based questions, just area you have to find. Okay, PV. First thing you have to remember here in this one, that C, molar heat capacity, is given by CV plus R by 1 minus X. C equal to CV plus R by 1 minus X, and they are asking question only based on this fact. In notes you will find other things also. You can see one time what things. Okay, I will send after the class. But C equal to CV plus R by 1 minus X, this one you have to remember. How question they will ask, they will give you here that if PV square equal to constant, PV square equal to constant, okay, for monoatomic gases, for monoatomic gas, find its C. PV square equal to constant, find its C. Okay, now how to know W is positive or negative? Work, expansion positive, contraction negative. In this, clockwise positive, anti-clockwise negative. Clockwise positive, anti-clockwise negative. All screenshot, array screenshots. Okay, I will send you. Okay, notes now, that will be better. Okay, notes I will send. CV, can write here CV. CV is your 3R by 2 for the monoatomic, plus R divided by, what is the X here? You can say PV power X equal to constant. In this one, X we are finding how much? 2. If X is 2, then we can put here 1 minus 2 in this. So here you can get 3R by 2 minus of R. Okay, we can answer this one. Okay, they asked for one time this question for PV equal to constant. Okay, we can easily find Miss P proportional to V. This was the question, P proportional to V. So X was minus 1. Okay, we can do. Okay, other things. Okay, we have done 3-4 numericals, but this is the only one important for our examination. Now, next thing in this one, we are having our heat engine. How to identify? If you are not able to identify your all your 4 process, that you know, isoconic, okay, adiabatic, isothermal, and your isobaric, then it is the it is your always polytropic. If you're not able to identify, then it is always polytropic without any doubt. We are having first one here, your okay, heat engine. Now, in heat engine, efficiency formula is basically 1 minus T2 by T1 into 100. Okay, this is the formula of efficiency, 1 minus T2 by T1. Okay, because I cannot explain mechanism, it will take a lot of time to explain. I will tell only what question is expected to be asked now. What they have asked earlier, because last year they didn't ask anything from this. I think before that also they have not asked. So this year more probability of heat engine is there, heat engine as well as refrigerator. Last year they didn't ask. 1 minus T2 by T1. And for refrigerator formula is, okay, you can see one time in your notes or in your booklet, whatever you have. Efficiency of this, we say efficiency at COP, and this is the T2 by T1 minus T2. T2 by T1 minus T2. Okay, now what question will be there in this one? I will take question on heat engine first. They will be saying efficiency of engine, efficiency of an engine. This question will cover two questions, so I am taking this one, is 40%. Okay, efficiency of an engine is 40%, and temperature of sink 27 degrees Celsius. Keeping temperature of source constant, keeping temperature of source constant, what should be, okay, or keeping temperature of source constant, by what amount temperature of sink should be reduced so that we get 60% efficiency. Okay, now, so this question might be asked because earlier they have asked only single question. In this one we are having mixing of two questions here, and last year they have not asked, so possibility is there for this. So what we can do here, first efficiency is your 40%, so we can use this 1 minus this T2 by T1 into 100 equal to your 40. First of all, this from the first line we can write this one. Now here we can say T2 by T1, you will get T2 by T1 equal to, we can say this will be the 4 by 10, and we can take here, so it is coming your 6 by 10, or we can say it is the 3 by 5. Temperature of sink is given, means T2 is given to you, there is a 300 Kelvin here. And if this is the your 300 Kelvin, we can say this is the T2 here. So I can write this is the 300 divided by your T1. So we can find how much T1 will be there. T1 is going to be in this one your 500 Kelvin. Till now they were asking only up to this, what is the temperature of source. Now what they are asking in this one, keeping temperature of source constant. Now source temperature you will take 500. Keeping temperature of source constant, so we can say now T1 is going to be 500. Now I want my new efficiency to be 60%. New efficiency 60%. Again you will use the same formula, so we can write 1 minus T2 by T1 into your 100 should be in this one 60. You can say 0 0 cancelled here, so T2 by T1 we can write, or we can say T2 dash and T1 dash. So T2 by T1 dash is going to be 1 minus 6 by 10, so we are getting here 4 by 10 in this one. Which temperature is constant in this one? Your temperature of source, T1 is constant, so we can take T1 value here in this one, so we can write here T2 dash by T1 is your 500 equal to 4 by 10. From here we can say T2 dash is coming how much? 200K. Temperature of sink is now 200. They are not asking what is the new temperature of sink. They are asking by what amount temperature of sink should be reduced. Earlier sink was 300. Now sink is your 200. So we can say temperature of sink should be reduced by 100 K. Then you will get the answer. This question you can do without, okay, without this formula also. How you can do this one? Because efficiency is your 40%. If efficiency is 40%, temperature of sink is 300. Means we can do like this here. That here, this is the 100. Here we are getting your 40. Here we are getting your 60. Actual temperature here 300. You can say this is the 5 times. So here also this should be 5 times, means 500. Those who are okay, who attended the class, they can get this method directly, okay, without using the pen. So we can say here, this is a 300, it must be your 500. We got this is the 500. Next time, what they want here, we can say next time they are saying here in this one that efficiency should be 60. So here 60, we can say here we are having your 40. This is your how much? This is your 500 fix 5 times. So 5 times of this we are getting 200. Now new temperature should be 200, means it should be reduced by 100. But don't try this one. Okay, if you are okay, you are not attending the class, you will go by formula. Formula will not take okay more than 90 seconds. I think it was clear. Mean free path can you do by yourself? Mean free path root 2 pi. This is the formula of mean free path. This one. D square mu. In this one, all particles are moving. So this is the root 2. If they say in the question, consider if only one particle is moving. Consider if only one particle is moving, then formula of this becomes 1 by, okay, your pi d square mu. Okay, both formula you will get in your notes. I will send the notes. Okay, so this thing you have to remember when all are moving, because in reality each and every particle is moving. First we derive this formula, use considering only one particle is moving. Joule's law is nothing, joule and calorie conversion. Okay, joule and calorie conversion, just you have to practice your questions. No radiation you don't have. Okay, radiation you don't have. I will send notes now. Okay, do those notes perfectly. There are the okay so many questions on okay these engines, as well as okay your work also you will find it will be having around 50 page, or I think more than 80 pages will be there. So it will take around 3 hours, 2.5 hours at least. So do your okay notes perfectly. Yes. Bye.